Okay, so I'm going to just go fairly as quickly as I can through this presentation. I think we've sort of started to catch up a bit of time, but we're still a little bit behind. On another initiative to improve safety of heavy vehicles on the road, but also reduce costs, and that would be reducing emissions as well. So I'm going to just explain the PBS approach to vehicle design, and I'll just tell you a little bit about the pilot project that's been running. We formed a committee in 2004, and the first PBS vehicles started operation at the end of 2007, and then I'll just show you a few results. Now, I showed you this slide a bit earlier and about how RTMS has had a positive impact, particularly in terms of vehicle maintenance and drivers. The main object of the PBS approach is to improve vehicle design and to make vehicles safer and what we call, in some cases, high-capacity vehicles. So their payload is increased and therefore their transport costs come down. Now, this approach to vehicle design started in New Zealand and Canada in the 1980s, and then Australia. So in fact, South Africa was the fourth country worldwide to look at a PBS approach to heavy vehicle design and operations. And in early 2000, we set up a committee and said, let's run a pilot project in South Africa to see whether this approach would be of benefit. And those are the areas that we're interested in: reducing road wear or road damage per ton of payload, reducing vehicle trips, improved safety performance, improved transport productivity, and reduced emissions. So typically, a heavy vehicle is a lot less stable on the road than a car, mainly because of its center of gravity, the height of center of gravity. So this is a clip. I've got a few clips here. This is in the States, going down a hill, a lateral acceleration. There's another one in, let's see if this one runs. Some of these may not run, which will save a bit of time, I suppose. Sure. This is bad. Nope. There's one that's in Cape Town. It's not too serious if all of them don't run. There's a truck coming around at an interchange. I don't know if this one will run. Interesting. Anyway, the Federal Highway Administration in the United States in the 1970s were concerned about truck rollovers in the States and commissioned the University of Michigan to do some research to look into the cause of truck rollovers. And that was where this whole concept of performance-based standards started. And it's really about looking at how the vehicle performs on the road rather than defining what it looks like. So the left-hand side is our prescriptive approach, which is how countries generally control the operation of heavy vehicles on the network. They define mass and dimensions, essentially, whereas the PBS approach looks at the on-road performance of the vehicle and sets certain performance standards. And I'll give you an example of a couple. It does allow heavier and or longer vehicles on certain parts of the network that are suitable. And it does also promote innovation. And I think maybe you'll see that through this presentation. I'm going to skip through this slide. This is the project timeline. I don't think we need to go into detail because of time. What we decided with the pilot project is that we would use an established scheme, which was the Australian PBS scheme that had already been adopted into their legislation. I think last year they approved over 1,800 PBS vehicles in Australia. So they're really moving ahead very fast, and they've identified all the benefits. So we're using this for our pilot project. And what it involves, and this is done through computer simulation, when you have a concept design that you want to run as a PBS vehicle, you simulate the vehicle combination with its payload doing a certain maneuvers, a low-speed turn, a high-speed lane change, a couple of others, and then you measure things. The things on the right-hand side are performance standards. So you measure those things, and they have to be within certain limits. And I'll show you a couple of examples. So I'll show you an example of low-speed swept path. I'll show you an example of high-speed transient off-tracking and rollover. So here you have a vehicle. When it goes around a corner at slow speed, now I hope these videos are going to play, the trailing axles don't follow the leading axle. So you get what you call off-tracking. So the truck takes up some space when it goes around a corner. And that space that it takes up is called the swept path. That's that dimension there. Sorry, that's a performance standard, that distance there. Now the regulations try and limit that swept path by limiting the length of the vehicle, limiting the wheelbase of a trailer. But it's definitely not directly proportional. So you can have a longer vehicle with a lower swept path. So limiting the length of the vehicle doesn't necessarily assure a safe swept path, which is important at depots. It's important when you're driving in cities where you've got intersections and pedestrians and cyclists and other motor vehicles. This is from Australia, and it's this is a legal truck tractor semi-trailer going around a corner, swept path, right? You see it starts to off-track. The next one is a legal vehicle that is 19 meters long. It's also a legal vehicle, 2 trailers, and you can see the increase in swept path, right? Now the next one is a 20-meter PBS vehicle. So it's 1 meter longer than the previous vehicle, but it's been designed to comply with the maximum swept path. So you can see it performs almost the same as the first vehicle. This is a legal vehicle in Australia. It's 25 meters long, 2 trailers, and it's got a very poor it's got a poor off-tracking performance. It complies with the regulations. And the last one is a 26-meter PBS vehicle in Australia. And you can see, because of the articulation points and some design features, it actually performs pretty well. And so that just illustrates to you the difference between a prescriptive approach, which doesn't necessarily ensure good performance, versus a PBS or a performance-based approach where you actually look at the performance and you measure that. All right, so now next I'm going to show you a high-speed performance. So there are 20 performance standards. So if you want to run a PBS vehicle in the pilot project, it must comply with all 20 of those performance standards. And that includes some infrastructure standards as well to ensure that the roadway is acceptable and the bridges are not compromised. So this is a high-speed lane change maneuver. It's not something a driver would do on a daily basis. It's more an emergency sort of swerve. And when we do these pilot projects, we also assess the baseline vehicle. So you come to participate, we say, okay, what's your PBS concept design look like? What is your baseline? What's the vehicle you're currently using? And this was a timber one of the first ones. This one on the left is the baseline vehicle, and it does this aggressive lane change maneuver, and it actually fails. The response of the trailer is too much that it's unstable. So that's a legal vehicle, 56 tons, 22 meters. It failed the test. And this one here is the PBS vehicle. It's 27 meters long. It's got a higher payload, 67.5 ton combination mass, and you can see it's quite a bit more stable when it does that same maneuver. So that illustrates again the main objective of the PBS approach is to make heavy vehicles more stable on the road so that the driver has got a better chance of avoiding a crash or a rollover. This one, the third one, is a rollover. You have a constant radius curve, and you gradually accelerate the vehicle until it rolls over. And you measure that force when it rolls over. And that force must be above a certain minimum limit. The blue one is the baseline vehicle, the blue vehicle, and the red one is the PBS vehicle. It's a 30-meter rig that's currently participating in the pilot project. But basically, in this case, the baseline vehicle rolls over much quicker than the PBS vehicle because it fails this rollover test. And we found that I think 75% of the PBS vehicles that we've assessed, the baseline vehicles that we've assessed in the pilot project have failed one or more, two or three of the performance standards. Right, there are standards for pavements or roads and bridges. I'm not going to spend time on that. But what this graph shows you, these are PBS and baseline vehicles in the mining sector. And the blue diamonds are legal vehicles. And that graph shows you the road wear or road damage per ton of payload. So the higher the value, the more road unfriendly the vehicle is. So you can see in all those vehicles, some of the baseline vehicles, these are mining site tippers, are very road unfriendly. Whereas all the PBS vehicles, which are the red squares, have been designed to be consistently more road friendly. So we do what we call a roadway assessment of the baseline vehicle and the PBS vehicle. And the objective is to make all the PBS vehicles road friendly, so it benefits the road authorities. So for example, the Coca-Cola vehicle, PBS vehicle that Jonathan showed, that one does about, I can't remember exactly, but somewhere between 40 and 50% less road wear per crate of beer or crate of Coke or ton of beverage or whatever. No, they don't carry beer. Hey, they just. And then there's a assessment that we do for structures, which I won't go into, but it's just to ensure that it's a performance-based approach to ensure that that PBS vehicle that's being proposed is safe in terms of the bridges. PBS in Africa. Some people argued with us that why run a pilot project when we've already got PBS vehicles operating, high-capacity vehicles. But look, let's be honest, these vehicles are probably not very safe, and they're probably causing a lot of road wear. We know overloaded vehicles, if they're not designed for the payload that they carry, can be very unroad friendly, can cause a lot of damage. So this is not the answer. Okay, just in terms of the pilot project, this is where we are sort of fairly recently, 282 PBS vehicles. So it's a lot less than RTMS. So RTMS, we said we're over 17,000 vehicles. PBS is a pilot project. It's a limited number of vehicles. Right now, we've actually done over 150 million kilometers. And the commodities that are being carried are fuel, timber, mining, coal, processed sugar, beer, buses, aluminium, passengers, sugarcane. You can see there's quite a range of commodities. And just in the last 2 weeks, Coca-Cola as well. And the most popular ones at the moment are fuel and timber. And then you can see the provinces that have participated the most are KwaZulu-Natal, Mpumalanga and Limpopo. We haven't had too much support from the western side of the country. I don't know why. But Western Cape, Northern Cape and Northwest Province are not really supporting the project. But we've been working with the Department of Transport to try and get all the provinces to participate in this pilot project so we can properly evaluate the value of PBS in South Africa. So we've developed a strategy in 2007 for the pilot project, and then we've developed the rules document. So if you're interested in participating in this PBS pilot project, you need to get a copy of the Smart Truck rules document, and that will tell you step by step how you come up with a concept design. You've got to identify the routes that you want to operate on, and a few other details. Of course, you need to get your RTMS certification, and then you can apply to the relevant provinces. We do route assessments if necessary to ensure that the vehicle can safely maneuver through a particular intersection if the road authority has some concern. So here's an example. There's another 2 examples where we checked a route going through an intersection and at a depot. So when you've got a longer vehicle, you want to be sure that, obviously you can negotiate certain things. sorry, that was, and then there's some route compliance reporting that's required. The map on the left is a forestry operation in KwaZulu-Natal, a monthly report showing the route that a particular PBS vehicle was using for the month. And the one on the right is up in Limpopo, a platinum operation, Anglo Platinum. We will also be introducing requirements for real-time monitoring in terms of speed and route compliance, so that the telematics companies are geared up to give real-time, as some of the operators have mentioned, if the vehicle goes off the route, they want to know about it. It could be a hijacking. So from a PBS point of view, because the PBS vehicles, most of them can only operate on certain routes, the road authorities want the comfort to know that those vehicles are sticking to the routes that they've approved. So that if the vehicle does go off the route, the logistics manager will get such an email. It could be speeding or route compliance, but also going to the road authority. So there's that transparency to say, okay, I'm going to operate these high capacity vehicles, but if they go off or if they are not compliant, you'll know about it immediately. These are some examples. The top vehicle is a legal vehicle in forestry, 22 meters long, 56 tons. I think most of you know that. And then these are some of the first PBS vehicles in forestry. There's one, this was one of the very first ones. You can see the RTMS board on the front of the truck. This is one in Mpumalanga. It's only 22 meters long, so it's not over length. What we allow our increased combination mass, but the axle loads we are kept to the legal limits. So in this case, that back trailer will be 18 tons on each tandem axle unit. In this case, it's got a twin steer, so that would be 15.4 tons. If you add that all up, I think this combination mass goes up to 67 tons, if I can remember correctly. So it's got a higher payload. It's not limited to the 56-ton limit. There's another longer one, longer PBS vehicle operating in KwaZulu-Natal, mainly on the N2 highway from Zululand down to Sapi-Saikor, south of Durban. This is a mining side tipper, 50-ton payload, 2 tridems running at 24 tons, and it's also not over length, it's 22 meters long. There are quite a number of these side tippers operating in the mining sector. And remember, this vehicle has got about Adrian, 40% reduction in road wear, 50 odd percent reduction in road wear per ton of payload, big reduction in the number of trips, and so the fuel, the liters per ton kilometer come down. So it's a win-win situation all round. And then we have a couple of road trains operating under the pilot project. This is one down at Richards Bay Minerals, but these ones will be typically in either very remote areas where the traffic volumes are very low, or on private roads. So that was what Unitrans were running originally. That wasn't a PBS vehicle, the top one. It was a road train operating under permit. But the bottom one, it's 42 meters long, 185 tons, but it complies with all the performance standards. And here you can see the baseline vehicle that they were operating failed this rearward amplification performance standard. So it's similar to the high-speed transient off-tracking, but it was actually quite an unstable combination. So with that pulse that you put in at the steering axle, the rear trailer actually rolls over. Whereas this one, which is the PBS equivalent, same maneuver, you can see how much more stable it is. So you don't know about this with your vehicle until if you're having a number of rollovers, the chances are that your vehicle design, although it may comply with the Road Traffic Act, it could be that it has some deficiencies in terms of the performance standards. This is a sugar bottom dumper, also 22 meters long, a side tipper in coal, running in Mpumalanga. also 22 meters. Then there's a fuel quad running mostly on the N3 between Joburg and Durban. These are all PBS vehicles. I'll skip through this one. There's a Beefmaster cattle PBS vehicle. This is the SA Breweries PBS vehicle operating in KwaZulu-Natal and the Eastern Cape, and it's very similar to the one that that Coca-Cola have started operating in the Free State and Northern Cape. So it's 30 meters long. It's got 11 axles. It's got steer axles that can greatly help the maneuverability. So it's got steer axles at this rear tridem axle there, and this rear axle on this tridem there are steer axles. So when it starts to turn, that axle turns. So it makes the vehicle much more, it improves the swept path considerably. So even though it's longer, it actually performs better than a standard 22-meter interlink. And of course, being a longer vehicle, it's limited to certain approved routes that have been approved by the road authority. So this vehicle is probably 95% on the N3 or the N2. When they started operating their 5 vehicles in the Eastern Cape a couple of years ago, I got some stats after 3.5 months. Just 5 vehicles, and they were comparing those 5 vehicles with their baseline vehicles that were already operating in the Eastern Cape. Now this is from the brewery to the distribution center. And they saved over 100,000 kilometers in the first 3.5 months. So less vehicle kilometers on the road. And the last column shows the fuel savings, about almost 27,000 liters of fuel saved, or 12.5%. ZZ2, Yapi showed you this one. I won't go through the overtaking. There's a biarticulated bus operating in Nelspruit. It's also a PBS vehicle. It carries 135 passengers seated. And I just saw an article, I think Kathy sent me, in Brazil. They've just started running these biarticulated buses as part of their bus rapid transit, a whole bunch of them that they've put on the road. The car carriers, a lot of them, well, just about all the major car carriers are RTMS certified and also PBS compliant. Their major problem in terms of performance was the tail swing of the trailer. So because of the requirements with the lighter payload, the nature of their payload, which are units of cars, their vehicles, their trailers tend to have large rear overhangs. And our legislation in South Africa allows rear overhangs, very large rear overhangs. So the tail swing, which is a performance standard, is the distance that trailer swings out when it does a 90-degree turn. So that distance there is the tail swing. So you can imagine when the driver's going around a corner, the more your trailer swings out, the more of a safety risk it is. Could be going through a gate, or there could be people standing there, or a traffic signal. So if that tail swing is very high, it just means there's going to be more incidents and accidents. And if you look at the Australian requirement, there's a maximum rear overhang of 3.7 meters. That's according to the Australian regulations. In South Africa, with our regulations, we can go up to 7 meters rear overhang. That's legal. So the tail swing in Australia is basically limited to 300 millimeters. It's about that much. Whereas in South Africa, we have vehicles, particularly car carriers, with tail swings that go up to 1.25 meters. So when the guy goes around the corner, the tail of the trailer swings out this much. Now we've introduced a roadmap for car carriers in South Africa based on PBS. So all new car carriers since 2013 must comply with the performance standards. So all new car carriers in South Africa now have a tail swing that doesn't exceed 300 millimeters. So this is not a high-speed sort of rollover type safety issue. It's just purely tail swing. A summary of the impact so far. The this was now a few months ago. We're saving with those 285 vehicles about 86,000 trips a year, or 22% savings in trips on average. The fuel saved on average is 12%, which means a 12% reduction in emissions. Greenhouse gas, you can see there, about almost 6,000 tons a year. And then the roadway reduction in roadway per ton of payload is on average 13% less. But the big improvement is with safety. So compared with the baseline vehicles, the crash rate of the PBS vehicles is at the moment 41% less. So there's a great reduction in crash rates. So I think I've already mentioned this about how so many of the baseline, sorry, not 70, it's 56% of the baseline vehicles that we've assessed in this pilot project fail 1 or 2 or 3 of the performance standards. So I'll skip through that. That's the crash rates. We've done some estimates on the cost savings in terms of crashes based on the RTMC cost of crashes report. A few months ago, in the pilot project, we saved close to 200 million. So that's basically an overview of the PBS pilot project. I don't know, is Chris Stretch still here? He was here earlier from the KZN Department of Transport. They're very supportive. His view is it's a win-win situation for all stakeholders, for the road authorities, for other road users, and for transport operators. So that's really what we're trying to demonstrate through this pilot project. So thanks very much.